Welcome everybody. In this video we are going to talk about how to use the air quality sensor, which is the sort of squarish kind of large sensor that you can see sitting on top of my matrix in the video. It's got a little fan on the side to take particles into it, and I think it uses lasers to figure out how many of what size of particles there are in the air. So we're going to learn how to get data from that, and we're going to see if we can't get a little basic visualization going on the Arduino. So you'll notice I am starting at the same place I always do with my base matrix sketch that is drawing a single red pixel to the corner of the matrix. You can see that on your screen. And I am going to walk you through the process of installing the library and getting the sensor started so that you can process the data from it. One comment I have is these can be kind of tricky to connect up using the little cables we have. So when you're ready to connect it up, raise your hand, let me know, and I will walk you through how to make sure you're plugging it in without breaking anything. So first thing we need to do is install the library. This is the Adafruit. You can see that I've already searched it. I've already got it installed on here. It's the Adafruit PM25 AQI sensor. So you can type in PM25 in here, and you'll get two different libraries installed, the Adafruit one. You'll have an install button there. Click on your install button. It won't say this. It'll say, do you want to install it? If it asks you to install dependencies, always say yes. Always install the library dependencies. So once you get this installed, we can do our standard thing of looking at the example sketch to see how it's going to work. So we can go to File, Examples, go down to the PM2.5 AQI sensor, and we can pull up the, I'm going to scroll this down a little bit. I'm going to try to scroll this down a little bit. There we go. We're going to pull up the PM25 test. So I'm going to open that sketch up, and we're going to take a look at this. We're going to test it, make sure that the sensor is working. You'll notice most of this is printing stuff out. This is actually a pretty simple sample sketch. A lot of times the sample sketches are a little bit of a pain to work with. This one's pretty simple. We've got our include here. We're creating our little object here. We are telling it to begin using the I2C communication style, which is the only one available to our particular sensor. And it's going to tell us it found it. It is reading the data, and it'll tell us if it can't read it. And then it is reading various things on the data object, right? This particular structure is going to look familiar from when you've been working with structs. So the data object, right, our PM25 underscore AQI underscore data called data, has a PM10 standard, a PM25 standard, a PM100 standard. We'll take a look at what numbers come out of these as we upload it. So go ahead and get this sample sketch opened up on your computer. I want you to upload it to your board with the sensor connected. And you should, when you open up the serial monitor, I'm going to open up my serial monitor right there. You should get some output, and then you should start to see a scrolling page of information off of the air quality sensor. Now, if you're using the air quality sensor, I'm going to encourage you to do a little bit of research about what these different things mean. But I will sort of talk you through the basics here. PM1, PM2.5, and PM10 are 1, 2.5, and 10 micron particles. They're usually used as an indication of air quality based on like how much particulate matter is in the air, right? If you cross a busy street, there's going to be a bunch of exhaust particles, stuff like that. So you're going to have a lower quality air at that sort of space, that slice of three-dimensional space. It's also giving us, this is 0.3 nanometers, 0.5 nanometers, 1, 2.5, 5, and 10. So this 2.5, 5, and 10, those are the 2.5, oh, it's got 5 too. So it's giving us a lot of information. My understanding, again, this is something you're going to want to do some research on, but my understanding is PM1, PM2.5, and PM10 are some of the better measurements of air quality. So we know we're getting data from it, but when you've got a sensor, you always want to test it and make sure that it's actually responding to changes in the environment. With temperature sensors, that's fairly straightforward. You can change the temperature. With light sensors, you can change the light level. With particulate matter sensors, you have to do something that's going to change the sort of amount of particulate matter in the environment in order to test it out. So I've got a cup of coffee, and it's hot. It just came out of the coffee pot, and they generate steam. So I am going to stick, this thing has a little fan, and that's to like guide stuff into it. So I'm going to stick it over the cup of coffee, and we're going to watch the numbers on my screen. and see if they go up. And it might take it a couple of seconds to read it. You can tell that it's starting to go up a little bit. Let's see. Yeah, there we're starting to get some PM1, PM2.5. So it's responding to changes in the environmental conditions, a lot of PM10s. Now this is probably mostly water vapor. I'm holding it over a cup of coffee, which is steaming. It's putting off steam. So these particles are not necessarily dangerous, but they are present in the air. So you can see that it is responding to being held over my cup of coffee. I'll take it off of the cup of coffee. I'll take the coffee off of the RGB matrix, which don't put cups of coffee on your RGB matrices, please. And we'll watch it as it sort of goes back to the default, or it goes back to reading the sort of room as a whole rather than the air directly above my cup of coffee. But we can tell based on this test that it is responding to changes in the environment. And more importantly, we know we have a way to test and see whether what we're doing with the matrix is going to work. Because if we're trying to make some display, you have to know that it's going to actually do something. It's going to actually do something in response to changing conditions. Okay, so we're gonna double screen, or we're gonna split screen this, and we're gonna start moving over the code we need into our base matrix sketch. I'm gonna close my little library manager. I'm gonna get rid of my serial monitor down here, and I'm gonna pull out just the code I need. So always need the include. That's what actually gets the library in there so we can use it. We always need to create the little object that we're working with. The vast majority of these create some sort of object that we then use to interface with the sensor. So let's take a careful look at what's going on here. We're starting our serial port. We're printing this out. So I'm going to copy these over. You'll notice it says we're waiting 1 second for the sensor to boot up. So if we don't do that, we're not going to get readings from our sensors. So we are going to copy this over, which is going to start the sensor after our 1 second delay. And then we should be able to read from it in our loop. So this is how we get the data object. So this is how we create the data object. We read from the data object using a format. We're going to go ahead and copy this whole if statement, because maybe sometimes we're not going to get a good read from it, and we want to be able to deal with that gracefully. So what this is saying is not, this exclamation point means not. So it's trying to run a function called aqi.read. It's passing in the data object we just created. This little ampersand means it's actually passing a memory location. Don't worry about that right now, but it basically lets the function change the data object in place. This is saying if it gives me a 0 back, or if there's a 0 there, which means it didn't work, we're going to say we couldn't read from it. We're going to wait half a second, and return is actually going to start our loop function over again. So it's just going to restart the loop. So once we hit this point in the loop, we know we have good data. So we can also tell what sorts of data we are going to get from this sensor by looking at these sort of complicated print line statements they do. So we can copy over these little individual variables that they're reading off of it. And I'm just going to put this in comments. So data.pm10_standard data.pm25, if I could type this would be easier, and data.pm100_standard. There's a bunch more. You can see all of these things over here. PM10_ENV, PM25_ENV, all these particles underscore whatever. Again, do some research on this. I'm not an expert on air quality measurement. I'm sure these have some relevance, but I'm going to use what I understand, which is the PM25_standard, which is a PM2.5 reading. So I can say something like PM int. Are those integers? Let's actually go back to this test sketch. It's important to understand what sorts of data we're working with. So let's make sure that we know what types of numbers we're getting out of this. Okay, so I actually have to get it to read something. I'm holding it back over the cup of coffee. Yeah, those are integers, right? So it is a count of the number of PM2.5 objects it's detecting in the atmosphere. So I know I can use an integer to store it. So int pm25 equals data.pm25 underscore standard. Now, I could just use data.pm25 underscore standard, but it's kind of nice sometimes to have a shorter variable name and one that's not attached to the object. And so I'm going to stop my auto scroll over here. I'm going to scroll back up. And I'm going to say that, when I hold it right over the coffee, it gets into the 60s. You probably will want to take a number of, if you were doing this for your project, then you'd want to use the technique we used in the second sensors video, where you're taking a bunch of readings and averaging them out over time. I'm not going to do that. I'm just going to get an instantaneous reading here, which is lower quality, but it's going to get us something we can test with fairly quickly. So I want to visualize my air quality by going from green to yellow or orange to red. And so I'm going to define some colors. And I'm going to use the old way of doing colors, which is going to be matrix.color 565. Red is going to be 25500. I prefer to use HSV, but it's pretty easy to define the colors here this way. We're going to define blue as, we said orange. As matrix dot color 565. Orange is red and I think a little bit of green. Let's try it. We'll figure out if it's not the right color. I'm going to define green. That's pretty easy as 0 red, 255 green, 0 blue. Okay, so I've got my colors. So really, I'm going to do something really simple. I'm going to say if PM25 is less than 20, I am going to draw a, I'm going to draw a green pixel. So I'm going to just use my little preprocessor directive here and say green. Otherwise, I'm using an else here. Else if, and I got to call this PM25. That's not going to compile. Okay, so if it's not under 20, I know it's above 20. So we're going to see if it's under 40. Then I'm going to draw it orange. And otherwise, that means it's above 40. I'm going to draw it red. Okay, let's see if this code compiles. This little check will tell you if your code compiles without uploading it. Oh yeah, this should say else if PM25 is less than. So that was just me skipping a part of my if statement. You'll notice I didn't read the error message there, and that's because the highlighted line was malformed. I could see that immediately, so I didn't need to go through the trouble of actually seeing what it was telling me. Okay, it compiles. I'm going to upload it. And we should see a single pixel once I upload it on the board. And it is green. Presumably, I'm not printing out any of my output. I could also do that. So let's actually go ahead and do that. But it should be green when it's under 20. So now we should get this output over here. We're actually going to get it in the serial monitor over here, maybe. Maybe not. Let's just close this window. We don't need this for right now. So I'm going to open up my serial monitor, and it's giving me zeros. Okay, so that's just my PM2.5, right? Which is what I am using as an index for air quality. If you are doing an air quality sensor, you'll need to do some research and see if that's correct. So I'm going to very carefully put this cup of coffee back on the board. You'll notice we got a little thing that said could not read from AQI. Sometimes sensors can be noisy and messy, so sometimes we just don't get reads from them. So now I'm holding it over the cup of coffee. You can probably see that in the video. I'm getting zeros, and if I remember correctly, it took a while for the, there's a 1. Let's see if it goes up back to zeros. The air quality the coffee might have cooled down enough that it's not putting off as much steam. We'll continue holding it up here for a little bit. Okay, so I'm seeing something I don't expect, right? I was expecting to see this go up when I held it over the coffee. I took it away from the coffee, and now it's at 1. So what I want to do here is see if there's something wrong with how I am reading in this data, or see if the cup of coffee is just cooled down enough that the sensor is no longer registering it. And the way I'm going to do that is I'm going to go back and open that example sketch again. It's not going to show up in my recent, so I need to go to examples, and it's the PM2.5 test. So I'm going to re-upload that, and we're going to see what this tells us, because this is sort of our gold standard for reading from the sensor. So, got it uploaded. We're going to open up our serial monitor, and now we are getting the more detailed information from our sensor. So let's see if we're seeing the same things. Okay, we're going to turn on auto scroll. Okay, perfect. So I'm going to hold it back over the cup of coffee. You're not seeing this because I'm not putting it back on the matrix portal, but I promise I'm doing it. So we're getting a 1, we're getting a 3, we're getting a 5, a 12, a 13. So that convincingly to me looks like good reads. Okay, let's take a look at this code and see if they're doing anything different, because we weren't getting those reads when we were doing this just now. They're delaying longer. They're delaying for a second. Maybe if we read from the air quality sensor too frequently, we are not getting good data. So let's try upping the delay to a second. I'm going to upload my test sketch that actually has the pixel in it back to the matrix, and we're going to see if we see the same thing happen with the air quality sensor. So we've got the 0 for the PM2.5. You can see the coffee again. And I'm going to hold this over it, and let's see if it changes now. And you can tell it's sending out new data a lot less quickly. So we're getting 1s, and we should expect to see this go up a little bit. Because if you recall, I'm going to switch hands so I can use my mouse. I don't want to drop this air quality sensor in my coffee. We look back over here, and we pull up the serial monitor. I got to turn off auto scroll. We got it up to 4. We saw some 5s. We saw 6s. So we should be seeing numbers that high down here. Turn auto scroll back on. Oh, we're getting 0s still. So let's re-upload this code. I'm holding this sensor here. By the way, this is the sort of testing I would recommend that you do if you're getting unexpected results from your sensors. Okay. Nope, it's still giving me 0s. I think the coffee's cooled down. I think we got lucky. I'm gonna look at this and maybe got a little bit of vapor off of it. But I think that it's cooled down enough that it's not really registering much. I'm gonna try it again. So a lot of times when you're working with sensors, you're just gonna spend a bunch of time testing them. Sometimes it takes a while to really get a good understanding of what the sensor is doing. So let's see if we can come up with a different way of generating some particulate matter. I'm going to turn on a soldering iron, and I'm going to burn a little bit of solder and see if that does it. Okay, so I've got my soldering iron moved over to this desk, and we are going to try and artificially decrease the air quality by melting a little bit of solder. You can see that I've still got my particulate matter sensor running, and let's see, I'm going to upload the sketch that has the pixel, because I think this is likely to work. So when it does, we'll want to see that pixel change color based on the air quality. So I'm going to take this soldering iron, and I am just going to melt, and you should see the little vapor go into that chamber. It's got a little tiny thing. You can see, oh yeah, went red immediately, right? So that generated a lot of particulate matter really quickly, partially because I was holding it right up to the thing. And you can see that's probably going to stay high for a minute. And then it'll go back down to normal. Now, you shouldn't take away from this that, burning a little bit of solder is going to dramatically decrease the air quality in the whole room, because you'll notice I was doing it directly in front of the air quality sensor, right? So all of the particulate matter generated by that went straight into the air quality sensor. And you can see it's coming back down now. So that was a way of sort of doing the most direct thing possible. You can see it's going back into orange. Now it's going back to green. So I'm gonna burn a little bit more solder back here, so you can see this is a little bit further away from it, and we'll see if that decreases the air quality as quickly. So you can probably see the steam coming off the soldering iron. And it goes up to 54, 66, 74, but it's not going back down to, it's not going up to 1,000, and it'll clear out a little bit quicker. So let's wait and let it go down. You'll need to do some research. I don't actually know if a PM 2.5 value of 80 is high or not. You'll need to do a little bit of research about what good values are. But we've confirmed that this sensor is successfully reading the environment, and that our code is changing the color of the pixel in response to what is being detected in the environment. Now it's staying up a little bit, possibly because I burned a little bit more solder, or possibly because this is actually a better read of the approximate air quality in this particular part of the room. So in a couple of seconds, we'll watch it go back down to orange, and then presumably to green. And then we will know that it is actually responding to changes in the environment the way we expect it to, and our code is responding to the sensor readings in the way we expect it to too. Okay, I'm gonna try something out. I've got a window right behind this setup. It's gonna bump the camera around just a little bit, but I'm gonna open up this window and we're gonna see if that does anything to the air quality. And these are things you can test in the classroom, right? You can take it outside. You can, ask me to use the soldering iron to get a little bit of solder fumes near the sensor. You can do all these things to test your air quality sensor out. And you'll notice I opened up the window and it went back down to 9. 9. What I would actually expect to see, based off of the air quality monitoring I have done in this space before, is like 5 or 6 is a good baseline. 10 or 20 is something you could reasonably expect to see, just sort of depending on environmental conditions. And above that, it probably means that something has happened to create some particulate matter. But test these sensors out on your own if you're going to use them. Do a little bit of research about what values actually mean what things. Don't just ballpark it. And you'll see it's bouncing around some now. I haven't done anything. The window's open. Some air from outside is coming in. There's a little bit more air circulation. So it's just going to probably bounce around like this. Basically forever. That's how sensors work, and that's why we do the thing where we average values to get less noisy data. But this should give you the basics on how to get started with the PM 2.5 air quality sensor. Like I said, do some research on what these numbers actually mean. I'm not an expert on air quality. This is just a video that's showing you how to get data off of the sensor. So if you have any questions, raise your hand, let me know. Otherwise, this is an optional video. There's no skills check. I would recommend, if you're watching this video, definitely get this code up and running. Let me know if you want to do some stuff to test the air quality sensor. But other than that, you're good to work on your project or any other optional videos that you think would be useful to you.